Antimicrobial resistance, AMR.
In order to understand antimicrobial resistance, we need to take a look at the exciting world of bacteria. These microscopic organisms exist everywhere. Bacteria can adapt and survive in extreme conditions. The ability of bacteria to adapt is linked to their capability to multiply very quickly and easily exchange genetic material.
When bacteria come into contact with an antibiotic, the sensitive bacteria will be destroyed, while the resistant bacteria will survive and multiply. Consequently, any use of antimicrobials will lead to the selection of resistant bacteria. Resistance can occur with various biochemical mechanisms, for example, through active efflux, reduced permeability, inactivation of the antibiotic by enzymes, and alteration of the antibiotic target.
AMR implies a limitation on treatment options for infectious diseases caused by resistant bacteria.
Is a concern on pathogenic microorganisms that can be transmitted to humans via food, milk, meat. Foodborne infections caused by resistant bacteria such as Salmonella and Campylobacter pose a particular risk to human beings because of possible treatment failure. As a consequence, livestock professionals are at risk of being infected by resistant bacteria through their contact with the animals they are working with. Moreover, meat or milk can still be a cause of microbial endurance. For an animal that has been treated with antibiotics, specific waiting time is set, which is a period where any derivatives from the animal cannot be released for consumption. This also means taking the antibiotic from the consumer, but in such a small dose that it is possible to produce resistant strains of a microorganism.
AMR disturbs familiar bacteria such as Escherichia coli or Enterocoli. Since many of these resistant determinants are located in the mobile genetic elements, bacteria can use the symbiotic flora to transport these genes to other pathogenic microorganisms. Therefore, we should use antimicrobial drugs in the best optimum way by taking into account the appropriate exposure time, the use of the correct medicine and the right dosage. For this reason, timely and accurate diagnosis of infection, appropriate knowledge on bacterial resistance, and new diagnostic tools are necessary. Prudent use of antibiotics in all areas and by all stakeholders should be a rule in order to control and limit AMR, as well as a tool for the treatment of bacterial diseases.
Infections requiring antimicrobial treatment should always be given after thorough consideration on how it can help avoid future infections. Let's stop AMR. Let's act for One Health.